All right, I'm not gonna lie, this is the third time I made this video. I'm having technical difficulties, so here we go. Find the length of this segment. This is 6.5 and 6.6, the study guides, if you want to follow along with what I'm doing. This one you already have. We did it the Friday we were in class last week. So it's all about proportions. Excuse me. So you have parallel lines as part of a triangle. Because it's within this triangle, these parallel lines are setting up two similar triangles. So our proportionality still works. So if you take the pieces of this side together in a proportion and set it equal to the pieces on this side, which AE, we don't know what that is. So I'm going to put X and 9. Notice I put the pieces across from each other that are across from each other in the diagram. Cross multiply, 12x equals 72. That piece that we don't know is 6. All about proportions. So this one, you don't know if they're parallel. You're trying to see if this and this are parallel. If they are parallel, it's making two similar triangles, which means our proportionality is going to work. Let's try it. 18 over 16 should equal 27 over 24. Again, I put them beside the number there beside. You can reduce each of these fractions to make it 9 over 8. So they are equal fractions. Or there's a little trick that if you cross multiply those two sets of numbers, those two products should be equal. If they're equal, then the lines are parallel. Moving on. When you have multiple parallel lines like L, M, and N in this example, with transversals like P and Q coming through them, it also divides things proportionally, because if these lines continued, they would make similar triangles. So the pieces that go together, 21 and 28, are the pieces broken up on that side. On the right, DE here, we don't know how long it is. So I'm going to put an X, and it goes with EF here, that's 32. So X over 32. Notice again, 21 is across from X, 28 is across from 32. Cross multiply, 28x equals that big number there. When you divide, 24 is going to be where we have our X, that piece that's missing. Last one for this section. We did not really do that much with this kind of problem, so make sure you pay close attention here. This bottom part, AC, the whole length of it is 33. This piece is X. So in order to find DC, you have to say 33 minus X, because the whole thing minus the piece AD there that's taken out. Now that you know DC, you can set up your proportions. 45 touches X. So those two go together. And then 54 goes with our 33 minus X. Notice my setup is different than what they did here. When you cross multiply, you'll get the exact same algebraic equation to solve. 54 times X. And then 45 times 33 is this, 1485. 45 times negative X, negative 45X. So here's your equation to solve. Combine like terms, divide. X is going to be 15. Again, proportions. 45 touches the side that has X. 54 touches 33 minus X. All right, 6.6, dilations. This is when you're making shapes larger or smaller. Quick little vocab review up here. Coordinate notation is with your X's and Y's and the little arrow about changing. The K in these stands for the scale factor. So what did you multiply your x and your y by in order to change them? That scale factor k for a reduction, the scale factor has to be less than 1 because you're reducing it, like taking half of the shape or a fourth of the shape, something like that. For in the enlargement, your scale factor is going to be greater than 1 because maybe you're multiplying by 2 to double it, or multiplying by 3 to triple its size, something like that. Like what we're doing in example 1. All right, here's the steps when you have a problem like example 1 to draw a dilation. First step, list out your original coordinates. Second step, see what your scale factor is, because that's what you're going to use to change your coordinates. Here is your coordinate notation. They've got that 3 scale factor in place because they know they're going to multiply all the x's by 3 and all the y's by 3. 0 times 3, 0. 3 times 3, 9. 2 times 3, 6. 3 times 3, 9. And so forth. So that's step 3, getting your new coordinates. Step 4 is to graph. A, B, C, D here is your original, your pre-image. And when you graph your new coordinates, you get P, Q, R, S, which they made up those letters. It didn't tell us what to name our image. So they graphed their new coordinates, which is the image. And that's it. It's a dilation. It got larger. Your scale factor was 3, so you knew it was going to get larger. Okay, this one, you have this photograph and you want to reduce it. So your original height is 8.5 inches, but when you reduce it, you want it to be 3. So it wants to know what's the scale factor. What did you multiply by? That's the key. Scale factor, you're going to multiply by something in order to change 8.5 into 3. 8.5 times what equals 3? Think about what I just said. 8.5 times what equals 3? Hey, there's an algebra equation for us to solve. Divide both sides by 8.5. And yes, you have a fraction there, but there's a decimal in your fraction. Don't leave that. To get rid of that 0.5 in the denominator, double it so it becomes a whole. So multiply your top times 2 and the bottom times 2. So 6 over 17 is your scale factor. Last, not least, you're missing a point. In this one, hopefully not missing the point, but in this one, you're trying to figure out what coordinate in the larger shape, the one that's dashed, would correspond with point J here. So we know it's going to be somewhere down in this area, so that when you finish out this shape, well, somewhere over here, when you finish out this shape, it's going to look like the smaller one. So list the coordinates you know. Here's F, G, H, and then J is down here because we're going to do something with it in a minute. F changed to A, so it changed here. G changed to B, H to C, and J is going to change down here. We're going to call it D. Okay. So how did they change? What happened? Well, from F to A, -1 times what gave us -4? 4. 1 in point G. 1 times what is 4? -1 times what is -4? Still 4. That scale factor is going to remain constant because remember, your proportion doesn't change when you have similar figures. So use that same scale factor of 4, but apply it to point J because we're trying to get the coordinates of this new point that matches up with J. So -2 times 4 is -8, -4 times 4, -16. Our new coordinate for point D is -8, -16. Thanks, and if you'll have more questions, you can email. Hope you have a good day.